October 12th, 2025. 8 days have passed without any fresh official word on the interstellar traveler 3EI Atlas, which is cruising by our sun while hinting at exotic extraterrestrial compounds. No sharp images, no direct explanations, just a neatly wrapped tale of an ordinary comet. But is that what it truly is? Doubts in this account keep growing. That's why this evening, we're stripping away the layers and posing the question on everyone's mind, though few dare voice it. Does the official version hold up, or is something bigger unfolding in the shadows? Sticking to our updated multi-segment approach, the disclosures grow even more ominous. We'll reveal the wandering black hole sneaking through the Milky Way undetected, a stealthy threat that might upend our assumptions about the galaxy's stability. We'll examine the massive gash ripping across the sun at this very moment, one poised to rattle more than just our atmosphere. Next comes the dire timeline. Experts caution that the cosmos could implode in a big crunch, and the clock is ticking faster than imagined. And as if that's not alarming enough, a steady stream of satellites is plummeting back to our planet daily, anywhere from 1 to 2 per day. So why the silence from the wider world? If these enigmas grip you like they do me, smash that like button and subscribe to catch every development as it happens live. Share in the comments. Where are you watching from? What's the local time? And do you think we're hearing the whole story on these game-changing finds? To boost this group, spread the word via X, Facebook, Reddit, or your personal chats. You folks make it possible for us to pursue tales like these, so thanks for the support. Segment 1. The entry sparking universal disagreement. July 1st, 2025, marked the arrival of an entity not originating from our solar system, but hailing from the vast interstellar void, instantly sparking suspicion. Odds are you missed the news. Most did, yet in the hushed labs of observatories and global research outposts, astronomers swapped secure emails, arranged urgent video meets, and puzzled over readings that defied expectations. They labeled it 3EI Atlas, cataloged as C/2025A1. The Atlas telescope array in Chile caught the initial glimpse, a dim blur shifting amid the stellar backdrop, following a path that defied logic. This became humanity's third verified interstellar visitor, succeeding the renowned Oumuamua from 2017 and Comet Borisov in 2019. Recall Oumuamua? That enigmatic, cigar-like form that sped up beyond gravitational pull, skipped typical comet venting, and slipped away into the starry expanse before we could study it properly. Atlas stood apart, or perhaps it mirrored the past. Consensus eluded them. The orbital calculations painted a straightforward picture. The thing followed a hyperbolic path, unbound to our solar system. It originated from some remote cosmic realm and would soon vanish into the void anew. Its approach velocity hit around 60 kilometers per second, roughly 130,000 miles per hour for those favoring earthly measures. Blazing quick, quicker than any craft we've built, outpacing the sun's breeze. So swift that reversing the math leads back to a sky zone devoid of any star capable of launching it. The body will hit perihelion, its sun closest point, on October 30th, 2025, skimming to about 1. For astronomical units from Sol. To clarify, 1 AU equals the Earth-Sun span. Thus, Atlas will dip within Mars' orbit, yet stay well clear of ours. Earth's nearest pass sits at roughly 1.8 Australian dollars. Distant enough to dismiss any real impact fears, even from the most alarmist. This bore no resemblance to melancholia or don't look up. The risk, if any existed, lay elsewhere than collision. Yet oddities accumulated like clues in a detective's file. Size assessments kicked things off. Early figures pegged Atlas at possibly tens of kilometers wide, dwarfing its interstellar kin. Rival projections clashed, proposing a tinier form but with odd reflectivity. Such variants felt off. Today's telescopes excel at gauging space debris. When sizes fluctuate by tenfold or greater, the object's makeup or form must be baffling our tools in unnatural ways for a basic comet. Then spectral analyses dropped, and they baffled everyone. Typical comets, as they heat nearing the stars, start venting their cores, vaporizing into stunning narratives that span millions of kilometers throughout the solar system. But Atlas defied that pattern. Spectral exams revealed carbon dioxide overwhelming the emissions, with hardly any water vapor in sight. Oddly enough, certain readings picked up elevated levels of nickel in the vapors, a substance that shouldn't show up in those amounts from a typical comet's release. One could expect stargazers to raise alarms about this everywhere. Picture urgent media briefings, hasty publications, observatories globally redirecting to monitor this odd newcomer. Bits of that occurred, no doubt, yet the overall reaction stayed subdued, restrained, loaded with caveats and possibilities. Plenty of experts openly regarded Atlas as merely an quirky yet ordinary comet, a deviation in the lineup, but nothing truly baffling at its core. Comets vary widely, they pointed out. Every star system boasts unique compositions. We can't assume incoming wanderers will mirror the makeup of items from our local stellar patch. Still, murmurs surfaced in the remarks under draft manuscripts, in hushed talks at gatherings, in secure messaging groups where scientists chat bolder than in formal publications. A few posed the query hovering on the fringes of acceptable discourse in today's astrophysics. Suppose Atlas isn't wholly organic? Suppose we're eyeing a constructed entity, a mechanical one, a dispatched artifact? Terms like probe started cropping up, often tucked into if-then scenarios and what-ifs. Alien got uttered even softer, typically paired with an uneasy chuckle, a cue that the utterer realized they were venturing into risky territory. Professional paths have suffered from embracing such ideas too eagerly. Standing has been earned by debunking them, but the figures ignored status. The makeup ignored professions. And with October looming, as Atlas closed in and our scopes captured extra glow from its exterior, the oddities refused to settle into tidy answers. If possible, they intensified. Thus, we're at this point. A visitor from beyond our star system is cruising our celestial turf at present. While you absorb these lines, it's exhibiting traits that don't align neatly with our templates for innate objects. The info at hand remains patchy, dispersed, at times clashing. And the organizations we rely on to unpack such puzzles are responding in deliberate, tempered voices that could signal prudent science or perhaps another motive altogether. No one's debating Atlas's peculiarity. All concur it's peculiar. The real issue is the nature of its peculiarity and who holds the say. Coming up, we'll probe the rhythms, the rotations, and the dilemma that torments a particular breed of researcher through sleepless nights. Is it broadcasting or merely drifting in emptiness? Section 2. Rhythms amid the blackness. Transmission or rotation. Illumination narrates tales if you're versed in deciphering it. Each particle of light hitting our instruments bears details in its hue, its alignment, its arrival. When experts examine something like Atlas, they go beyond spotting a speck overhead. They're dissecting shifts in that speck's intensity across periods, building a luminosity profile, a chart plotting glow versus spans of hours, days, months. Typical comets yield disordered, erratic luminosity profiles. They spin haphazardly across the void, their spins thrown off by the lopsided thrusts of venting, their exteriors riddled and uneven. The glow shifts we observe are basically static, erratic swings as varied facets snag sunlight from differing perspectives. It's the visual counterpart to random buzz, foreseeable solely in its chaos. Atlas bucked this trend. Or put differently, it partly did and partly didn't, which could unsettle even more. The luminosity profile displayed shifts that stood out for their consistency. Intensity alterations recurring on specific intervals, hinting at organized form over wild spinning. Parts of the records revealed cycles that had observers hunching over screens, verifying their setups, questioning if their eyes deceived them. The precise label is photometric periodicity, and it's precisely the sort of rhythm you'd anticipate from a vessel intentionally turning to manage its bearing, or from a scout meant to beam signals across the stars, or from various crafted setups needing exact handling of rotational force. Truthfully, it's also feasible for an innate form with a distinctive yet accountable contour. Maybe a paired body, twin parts linked by a slim bridge, whirling in a steady setup. Then the alignment readings came in, and matters escalated in strangeness. Alignment gauges the orientation of light's oscillations. As they journey through the cosmos, polarized rays oscillate along particular axes at right angles to their trajectory. In contrast, unpolarized rays fluctuate randomly in every possible direction perpendicular to their route. When light becomes polarized, its intensity and orientation reveal details about the traits of the material that bounced or dispersed it. Textured terrains tend to scramble polarization. Sleek ones, however, generate pronounced polarization signals. Particular configurations can yield negative polarization, flipping the expected alignment in an unexpected way. Comet Atlas exhibited intense negative polarization from specific viewing angles, results that stretched beyond predictions from models of typical natural materials. One study labeled it as unusual polarization patterns clashing with conventional comet dust theories. Another referred to it as geometrical albedo traits hinting at structured, non-uniform surfaces. Such precise, hedged remarks are how experts signal something puzzling without fully committing to an explanation. Picture a lighthouse. Its ray sweeps the sea in steady cycles, delivering a rhythmic signal to anyone watching. Now envision that structure spinning wildly across the void at 60 kilometers per second, bouncing back sunlight in sequences that seem too patterned for chance alone, yet too erratic to confirm as engineered. That's roughly the enigma at hand. It could serve as a signal. Or perhaps it's merely space's most awkwardly formed boulder. The measurements of non-gravitational forces introduced further complexity. By monitoring a body's path with high accuracy, researchers can spot subtle shifts from a purely gravitational trajectory. Comets routinely display these shifts. Jets of gas function like feeble thrusters, nudging the nucleus askew based on emission sites across its exterior. In ordinary comets, these influences balance out symmetrically over periods. But for Atlas, the acceleration patterns resisted fitting into routine gas ejection frameworks. A few experts suggested it was a particle-heavy comet, essentially a grimy stone ejecting mostly solid debris instead of vapors, with momentum arising from sunlight pressing on those grains rather than gaseous bursts. This idea accounted for certain compositional quirks and motion irregularities. It offered a solid middle ground between an oddball comet and an extraterrestrial artifact. Sure, it left gaps, but it held up as a credible theory. Perhaps that's all there was to it. Perhaps Atlas just inhabited an underexplored corner of the spectrum for celestial wanderers, prompting tweaks to our frameworks instead of a total overhaul. The cosmos owes us no clarity. It remains unmoved by our befuddlement. It simply exists, unconcerned with our need for tidy classifications or reassuring answers. Yet what lingered in the minds of those poring over the brightness variations until dawn was this. If designing a spacecraft for an interstellar voyage, one detectable yet subtly engineered, teetering between drawing notice and mimicking a stone, what shape would you choose? Likely something broadly organic-looking, easily waved off as a comet or asteroid, but with subtle symmetries precise enough to intrigue sharp-eyed analysts. You'd build in vagueness, plausible excuses, debates among watchers over the true nature. And that's precisely the scenario that unfolded. The radio scans turned up zilch. No obvious repeating pulses, no encoded transmissions, no broadcasts screaming across the spectrum as artificial constructs. Still, lacking proof doesn't prove a lack. Especially given our scans covered just a sliver of bands. Our dishes track narrow patches, and the object's velocity smears signals via Doppler effects into potential unrecognizability. Thus, we're stuck with open-ended clues, patterns that could signal intent or mere rotation, compositions possibly otherworldly or born from an unfamiliar star-forming zone, motions attributable to venting or alternative causes. Each observation offers dual, or triple, readings, and resolving them demands data we lack or a bold assumption one way or the other. How does this stack up against prior interstellar intruders we've spotted? What lessons emerge from past oddballs that defied norms? Next, we delve into Oumuamua lingering enigma and the insights it imparted. It teaches us about gaining true insight. Part 3. The Shadow of Oumuamua. On October 19, 2017, the Pan-STARRS telescope in Hawaii spotted an anomaly gliding across the inner solar system along an improbable path. Initially, experts figured it was just an asteroid or comet originating from our own Kuiper belt, nudged closer by some gravitational nudge. Yet, as additional data poured in over the following days, the orbital analyses pointed to an unsettling reality. This entity, quickly dubbed Oumuamua, Hawaiian for scout or messenger, had journeyed in from beyond our stellar neighborhood. For the first time in recorded history, humanity had verified an intruder traversing our solar system from afar. The inaugural occasion, we could assert with certainty that we were observing a guest from a distant sun, and it was outright peculiar. Oumuamua gained speed as it swung away from the sun, a modest yet detectable boost that gravity couldn't fully account for on its own. It lacked any cometary coma, no venting gases, no evident traces of the icy volatiles that ought to vaporize under solar heat. From how its luminosity fluctuated during rotation, its form appeared strikingly extended, possibly tenfold longer than broad, a configuration almost unheard of in typical asteroids or comets. Certain projections extended the slenderness even more, hinting at a needle-like or cigar-shaped profile that upended standard origins theories. Researchers unleashed a flurry of studies offering earthly rationales. Perhaps it stemmed from a shattered planet ripped by tidal stresses. Perhaps its makeup involved odd substances that didn't release gases noticeably. Perhaps the speed-up arose from evaporating hydrogen frost, too subtle to spot, yet potent enough for propulsion. Perhaps. Every theory patched one issue only to spawn fresh puzzles. Every notion demanded exceptions, relying on rare scenarios that seemed plausible yet unproven, handy but unsubstantiated. Then came Avi Loeb's voice. Loeb, head of Harvard's astronomy division, a researcher boasting a stellar track record and ample clout, openly floated the notion that Oumuamua might be manufactured. He floated the idea of it being a light sail, a slim, mirroring membrane driven by stellar radiation, either a relic of extraterrestrial engineering adrift in the void, or bolder still, a functioning emissary from an alien society. The academic world fired back with outright outrage. Loeb faced charges of hype, tarnishing the field's image, ditching methodical inquiry for media buzz. The backlash was so raw, so gut-level, that it sparked its own inquiries into why notions of alien artifacts triggered such fierce pushback. 2 years on, in August 2019, a second interstellar arrival showed up. Labeled 2I/Borisov, it acted the part of a classic comet. It vented as expected, sported a clear tail, and revealed chemical makeup aligning with our local comets. The astronomical circle exhaled in unison. There, they implied, visitors from afar mirror our homegrown ones. Oumuamua stood out, yet proved interpretable in the end. All's well. Back to business as usual, except Oumuamua refuses to let us settle. In several respects, Atlas echoes Oumuamua more closely than it does Borisov. Each exhibits unusual speed-up, defying basic orbital physics. Each boasts traits, chemical or structural, that don't fit neatly into our classifications. Each straddles the line between icy body and stony relic. Neither fully fits either box. But Atlas could dwarf Oumuamua if the measurements hold true. It features that odd carbon dioxide lead venting unseen in the others. Plus those nickel traces, that intense polarization, those rhythmic light shifts, all thrust it into uncharted ground. Ground where our easy comparisons crumble. Where Atlas diverges most sharply from its kin lies in the uproar it stirred. For Oumuamua, we felt astonishment, puzzled over the sights, open to diverse theories. For Borisov, relief washed over us, a rush to slot it into known bins. With Atlas, the field appears to have preset its stance before the full data emerges. Post-Oumuamua uproar, amid the claims and rebuttals, after seeing a prominent peer vilified for probing tough topics, plenty of stargazers seem to have subconsciously opted for caution, to spotlight mundane causes, to downplay oddities. This amounts to overcompensation. Get scorched by a blazing burner, and you might shy from every appliance, even cold ones. Suffer a field singe from alien tech chatter, and it could turn hyper-skeptical toward any clues veering that way. Despite compelling evidence that warrants close scrutiny. The lingering emotional echo from the Oumuamua controversy could be shaping current views on Atlas, fostering a preference for standard theories that's every bit as unrigorous as leaping to conclusions that every oddity is man-made. Avi Loeb has diligently documented these irregularities, contending that our analytical lenses are inherently skewed against detecting signs of advanced tech. He highlights our own proven instance of a society building interstellar craft, plus the fact that we've dispatched probes past the boundaries of our solar system for years. Suggesting that some other society might achieve similar feats isn't far-fetched conjecture. It embodies the principle of mediocrity, the belief that humanity isn't unique, and events unfolding here likely unfold in other places as well. Should the proof for ordinary origins fall short, if we're resorting to ever more elaborate scenarios to uphold traditional views, perhaps we're overlooking the most straightforward account, which is tough to swallow only due to its profound ramifications. Context from the past is crucial in this discussion. In astronomy's long chronicle, we've repeatedly stumbled upon celestial bodies that appeared bizarre, resisted easy interpretation, and sparked ideas of non-natural sources. When pulsars were first spotted, astronomers half-jokingly dubbed them LGMs, little green men, owing to their rhythmic radio signals that felt too exact to be random. Quasars upended our grasp of energy output from compact spatial regions. Fast radio bursts continue to elude a fully convincing origin story. Time and again, we've uncovered natural processes accounting for these phenomena, processes that turned out to be more exotic and captivating than any engineered alternatives. Yet, the key point remains: prior natural resolutions for oddities don't assure that all enigmas stem from nature. That's inductive overreach, presuming past patterns dictate future ones. Eventually, if genuine traces of alien engineering surface, they'll appear irregular. They'll clash with our existing paradigms. They'll ignite debates just like this. And should we condition ourselves to routinely reject tech-based ideas, to always contrive some natural cause however forced, we risk bypassing humanity's greatest breakthrough, all because we'd prefer the comfort of error over the unease of truth. So, what position does that put Atlas in? Spinning across the void in the space between assurance and guesswork, detected by tools that glimpse partial realities but miss the full scope. This leads to what might be the story's most disconcerting feature: the absent information, the photos that ought to be available yet remain withheld, the voids in the official archive that could be harmless oversights or indications of deeper issues. Let's probe what's lacking and why its absence could outweigh the visible evidence. Part 4. The issue of unreleased data. Contemporary astronomy thrives on vast troves of information. Orbiting scopes, gear on the red planet, stations dotting every landmass. We're equipped to react. When a noteworthy visitor ventures into the inner solar system, scores of devices can train on it, snapping shots in various spectra to assemble a thorough profile of the intruder. At least, that's the ideal. Reality, especially regarding Atlas, diverges sharply. The European Space Agency shared an output from the Cassis instrument on the ExoMars Trace Gas Orbiter, a boon repurposed from its role in detailed Martian terrain mapping to photograph Atlas amid its nearer pass by the planet. The result? A dim speck drifting amid the stellar backdrop, a blur scarcely separable from static. A snapshot verifying Atlas's presence and predicted position per trajectory math, yet offering zilch on its material makeup. For something purportedly dozens of kilometers wide, entering the sight line of a sharp imaging device, the scarcity of specifics was maddening. Either Atlas measured far tinier than certain projections, or it absorbed light unusually well, or the aiming fell short, or various elements teamed up to deliver the most opaque view imaginable. Additionally, the Perseverance rover, NASA's premier red planet endeavor, fitted with sky-scanning cams for spotting whirlwinds and vapor formations, snagged Atlas on October 4th as it crossed the Martian heavens. What emerged from that capture? A trail, a luminous streak aligning with an entity traversing the starry field. Timing and trajectory syncing with Atlas's forecasted route. Once more, validation sans insight. It affirmed Atlas's location and motion as anticipated, but shed no light on its essence. Such visuals were disseminated, highlighted in announcements, and covered in media updates, and fresh scientific reports provided scant details on the matter. And perhaps that's acceptable. Perhaps these tools just weren't built or aligned to deliver more robust information. Yet this is where things turn peculiar. Additional sensors ought to have recorded visuals, superior visuals, yet none have surfaced. The Mars Reconnaissance Orbiter features HiRISE, the high-resolution imaging science experiment that can discern surface details on Mars down to 1 meter in size. Upon an interstellar visitor drawing comparatively close, one would anticipate HiRISE being assigned to snap numerous photos, following the intruder over multiple passes to compile a thorough collection of info. So where are those shots? The MAVEN probe, focused on Mars's upper layers of air, includes optical gear that might have offered useful sightings. Whatever happened to that information? The Mars Odyssey satellite, active since 2001, boasts heat-sensing tech that could have spotted thermal traces or evaluated the visitor's outer warmth. Has any of that been made public? The standard responses, whenever they appear, cite detection thresholds, timetable clashes, or equipment limitations. HiRISE targets ground landscapes, not swift space wanderers. MAVEN's setup prioritizes air studies, not rock pursuits. The workflow for handling data demands time, fine-tuning, and checks prior to sharing. Plus, don't forget the federal budget freeze in early 2025, which stalled many NASA efforts and piled up a mountain of pending analysis jobs that's only now getting cleared. Such justifications hold water. They make sense. They could well be spot on, but they unfold amid a backdrop where missing info breeds room for rival stories. When folks anticipate viewing certain things and come up empty, when organizations known for meticulous logging abruptly show holes in their files, doubt rushes to occupy the void. There's a storied past of accusations that cosmic programs have altered, postponed, or suppressed oddball visuals. Take the famed face on Mars, a mere hill sculpted by wear and light play, though first shown without clear context, that schooled a whole era to doubt NASA's photo drops. Countless wild theories insist that shots from moon voyages, rover treks, and sky scans have been wiped or softened to erase signs of buildings, relics, or bizarre oddities. The bulk of these ideas are baseless, mere tricks of the eye on static, spotting intent in chaos. Still, a bunch of bogus notions don't render all notions bogus, nor do they guarantee that groups always disclose tricky findings openly. The European Space Agency follows a half-year hold on many raw files. Sites and readings get gathered, refined in-house, tapped by expert groups, and solely afterward uploaded to open stores. This routine safeguards pro's time to probe before broader eyes fall on it. It's sound science and logistically essential. It also implies that crisp views of Atlas could be tucked away in ESA vaults at this very moment. Views unavailable to everyone until somewhere around mid-2026. Views that could settle debates swirling in this informational blackout. This sparks what's termed the info void phenomenon, when everyday people learn that captures should have happened but remain out of reach. When the divide between what got spotted and what's out there swells enough to stand out, tales hurry to plug the hole. Among those tales, some veer toward paranoia, some lean conspiratorial, some suggest hush-ups, hidden truths, and official deceit. And some could prove right, or at least partly so, since a lack of proof can signal proof of nothing when you were counting on that proof to show up. Think about the driving forces involved. If Atlas turns out to be merely an odd comet, dumping every bit of data pronto poses minimal danger and boosts knowledge gains. If Atlas proves murkier, perhaps engineered or displaying traits beyond our grasp, putting that out there stirs trouble. It draws fierce examination. It sparks queries the outfit might not be set to tackle. It could expose strengths or weaknesses in our gear that folks would rather shield. It hazards widespread alarm or bewilderment if the meanings hit without fitting framing. Nothing here confirms concealment, but it lays out believable reasons for picky sharing and shows that the spread between sightings and disclosures exceeds what normal research prudence would account for. Your urge to believe that the bodies probing Atlas are delivering the complete view, even as they admit much of the view stays locked away for review for months or even years. It's a tough challenge, especially with so much riding on the line. That leads us straight to the core issue driving this whole inquiry. Why does it count? Should Atlas turn out to be a natural phenomenon, we pick up some fascinating insights into the chemistry across the stars and carry on. But if it's man-made, or whatever the interstellar equivalent might be, that would rank as the most monumental discovery in our species' story. Yet, looking past those stark scenarios, The true weight lies in our approach to interpreting these oddball objects. What are we truly grappling with when we argue over whether Atlas is merely a comet or something stranger? Let's delve into the nature of conviction and the price we pay for it. Section 5. Conviction, doubt, and the risks involved. Consider this straightforward query. Why should it make a difference if Atlas is nothing but a comet or potentially something grander? How would that alter your daily routine, your aspirations, or your sense of where you fit in the grand scheme of the cosmos? Depending on the verdict, say, if Atlas proves entirely natural, with all its peculiarities boiling down to routine chemical and physical processes, we get a precious glimpse into the makeup of a distant solar system. We discover that worlds light years off can spawn comets bearing chemical profiles unlike our own. We'd realize that the processes shaping stars differ more widely than anticipated. We'd see the cosmos brimming with variety that we're just starting to map out. The payoff is solidly scientific, stimulating to the mind, another piece in our growing puzzle of universal makeup. We draft studies, tweak our theories, and shift focus to the following enigma. On the flip side, if Atlas is the product of design, if we're peering at signs of alien tech, the world flips upside down. No exaggeration here. Verifying that smart life thrives out there, that societies can emerge and endure long enough to dispatch scouts across the void, that solitude isn't our fate. It would mark the pivot point splitting human chronicles into before and after. Our notions of importance, destiny, and duties to the stars would all reshape in an instant. But that's the tidy binary. The Messier puzzle unfolds in the gray zone of doubt where we find ourselves stuck right now. Because at this moment, we simply lack certainty about Atlas. Data pulls us toward conflicting conclusions. Organizations issue statements we can't check on our own. Information voids could stem from harmless oversight or deliberate secrecy. And we, the everyday observers, are pressed to form opinions sans the complete picture. This is where the mental toll kicks in. How our kind handles the prospect of initial encounter, or even vague suggestions of it, lays bare our essence as a collective. Do we greet the unfamiliar with wonder or apprehension? Do we press for openness from our establishments or yield to their expertise? Do we dare explore unsettling ideas or hunker down in reassuring absolutes? No matter the final verdict on Atlas, this episode gauges our society's readiness. Institutions face pressures too. Agencies exploring space rely on taxpayer dollars and governmental favor. Their resources hinge on upholding trust, projecting rigor and empiricism over guesswork and hype. Should outfits like NASA or ESA declare they've spotted alien artifacts only to be proven off base, the blow to their standing would be severe. Budgets might shrink. Heads could roll. Upcoming ventures might get axed. Such dynamics encourage restraint, a push for ironclad proof before speaking out. That's reasonable, relatable, all too human. Yet it breeds a slant that might blind us to real outliers, since owning up to them invites career hazards. Add in the peril of selective seeing, confirmation bias, where fresh findings get twisted to bolster preconceptions. Crave Atlas as an otherworldly scout? You'll spotlight the quirks and brush off the mundane takes. Each quirky reading fuels your theory. Each info shortfall screams conspiracy. No deceit at play, no willful folly. Just the usual human habit of sifting facts through personal hopes and priors. Counter that with the flip side, rejection bias, the urge to shove aside jarring options no matter the proof. Wedded to Atlas as a plain old rock, you'll amplify the standard accounts and minimize the weirdness. Each quirky reading shrinks to a trivial knot. Each info shortfall passes as routine lag, not shady holdback. No foul play intended. Just shielding from the unease of appending core truths, the disorientation of seeing your cosmic worldview rocked. Each pitfall ensnares us. Each veers from reality. The real test: can you juggle rival ideas at once, weighing them by data over wishful thinking, refining, updating your views as fresh evidence comes in, instead of stubbornly holding on to first impressions no matter what the cosmos reveals? This ties into a broader philosophical debate. Does faith in alien spacecraft represent a contemporary legend? A tech-era stand-in for deities and celestial beings, mirroring our aspirations and anxieties across the stars? Or does it stem from logical deduction based on the evidence at hand? drawing on Bayesian principles, which indicate that considering the universe's vast scale and antiquity, the abundance of worlds that could support life, and our own emergence as evidence that sentience is possible, the probabilities tilt toward other societies out there, perhaps dispatching scouts across the emptiness. The resolution isn't straightforward. Each side holds weight. Both can summon solid arguments and reasoning to support their case. What stands out is the question's deep significance, not only for deciphering Atlas, but for grasping our own essence. Are we isolated? If not, what would encounter imply? If extraterrestrials are dropping by, watching us, or just passing through from distant realms, what duties does that impose on humanity? These aren't mere intellectual ponderings. They pose urgent issues with real-world consequences for resource distribution, long-term strategies, and our perception of humankind's place in the grand stellar narrative. And here's the harsh reality. We're shaping these choices, building these convictions, and tackling these dilemmas amid partial knowledge. The complete records are out there someplace. Photos that might clarify uncertainties. Spectral analyses that could validate or debunk theories. Viewing logs allowing a sharp look at Atlas, free from the haze of partial disclosures and official restraint. Yet that information remains out of reach. We're urged to have faith, to yield judgment, to believe that experts with superior insight are wisely choosing what to reveal and what to keep under wraps. Perhaps they are. Perhaps the organizations probing Atlas possess compelling justifications for their outreach methods. Perhaps all their actions are rigorously scientific and morally upright. But the setup of the scenario, the imbalance in knowledge, the divide between hidden facts and public scraps, that framework itself breeds doubt and conjecture. When authorities handle the populace like kids unable to face tough realities, they can't feign shock if folks begin suspecting a major cover-up. Thus, we're stuck in ambiguity. An interstellar guest exhibiting traits that defy our theories, spotted by tools whose readings aren't wholly disclosed. Analyzed by entities with intricate agendas. Atlas lingers overhead, both physically and symbolically. A cosmic enigma etched in stone, alloy, or whatever unknown substance. And we're expected to form opinions on it sans the details required for sound judgment. But Atlas isn't the sole oddity unfolding in the heavens these days. Latest findings and current astronomical updates could offer background, counterpoints, or hints for making sense of this wandering celestial body. In the following segment, we turn to recent space developments, to peculiarities and occurrences that could connect, or merely coincide, or represent something more profound. After all, unraveling one puzzle often demands examining the cluster of enigmas around it. Often, the bigger picture emerges only when you pull back to survey the entire expanse. Part 6. An orphan black hole. Picture the heaviest entity imaginable. A neutron star? Not dense enough. A galaxy's heart? Too fixed in place. Now envision matter equivalent to multiple suns squeezed into a space tinier than a metropolis. Twisting space-time to such an extreme that once the boundary is breached, escape proves impossible for anything, light included, from its pull. That's a black hole. Now unleash it. Sever ties to any galaxy, any star cluster, any binding force. Let it roam the interstellar gaps. A stellar hunter prowling the shadows. In 2025, skywatchers verified sightings of what's dubbed a wandering black hole. A star-sized one untethered from any clear orbital path, gliding across our Milky Way like a spectral vessel navigating unseen harbors. This isn't wholly unexpected on paper. Such voids arise from the implosion of hefty stars, and the forces shaping star paths in the galaxy can sporadically eject a black hole from its origin group, launching it into solitary transit. The shock lies in spotting it. Black holes notoriously evade direct sight, betraying presence solely via their tug on surrounding stuff or the glow from infalling debris. A lone rover black hole, lacking a partner star, no swirling debris ring, no handy fuel to devour and flare up, stays virtually invisible to standard detection. The breakthrough relied on gravitational microlensing, a method leveraging Einstein's theory of general gravitational lensing occurs when a hefty body glides across the line of sight to a distant star, warping the star's light through its immense pull and producing a fleeting surge in brightness before it fades as the positions shift. Astronomers gauge these fluctuations in intensity to deduce the intruding body's size and speed. Here, the microlensing pattern pointed to a dense, shadowy entity boasting a few times the Sun's mass, traversing the Milky Way's disk at speeds matching those of a dead star rather than a typical one. This verification mattered greatly, as it backed up long-held theories and opened a window to spot a class of entities predicted to abound, yet seldom glimpsed. Simulations indicate that the Milky Way harbors hundreds of millions of black holes with stellar heft, leftovers from long-ago stellar explosions, most utterly hidden and beyond detection save when they align precisely with a far-off light we're watching. Our galaxy teems with unseen traps of gravity, ravenous voids in the fabric of space-time ready to swallow anything that strays too close to their boundaries. Now, tying this to Atlas sparks some intriguing thoughts. Might a free-floating black hole have nudged the path of our cosmic guest? Could such a gravitational brush account for the odd path we've noted? On the surface, it feels believable. These black holes pack a tremendous gravitational punch. Even a far-off brush could veer an object's course, perhaps clarifying how Atlas arrived in our solar system from its home star system. However, the calculations fall short. We grasp gravitational effects thoroughly, guided by formulas refined through rigorous trials. To substantially bend Atlas's route without snaring it or boosting its speed further would demand an extraordinarily precise brush, one akin to hitting a pinpoint target in vast three-dimensional voids spanning light years. Feasible, sure, since physics doesn't rule it out. Probable, though? Not really. The cosmos offers plenty of mundane ways for paths to shift sans rogue black holes. Still, there's a poetic echo in these twin oddities surfacing together in our view. A homeless black hole and an origin mysterious comet, both adrift in the void, both appending our neat classifications. They both underscore how the galaxy pulses with greater flux, turmoil, and lurking perils and enigmas than our neat textbook sketches imply. We picture space as vast emptiness dotted with sporadic bastions of mass and glow. Truth be told, it's far more disquieting. Space brims with the unseen. Colossal forms slicing through the black, relics of exploded stars cruising amid the visible ones. Rogue black holes also prompt uneasy queries about other drifters lurking beyond. If stellar corpses can get flung from their origin clusters, why not planetary debris? Or items never tethered by gravity at all? Or perhaps artifacts set on courses by intent, not mere chance tugs? The tally of interstellar wanderers stays largely a blank slate. We only catch those beaming or bouncing light our way. All the rest, the everyday dark stuff, not the grand cosmic kind, stays cloaked until it drifts near our scopes for a peek. This ties into a broader thread in our probe. Space reveals itself as far from the serene, foreseeable realm we once envisioned. The neat orbital dances around central poles get tangled by these outliers and nomads, defiers of the expected flow. And if our models err on black holes, on the count and character of star-spanning drifters, what other flaws lurk? The timing feels oddly pointed, too. It's 2025, and we're charting this peculiar interstellar wanderer across our system, while affirming lone black holes prowling our galaxy. These revelations may not link directly. Astronomy churns out fresh insights nonstop. Yet the bunching of quirks, the pileup of bizarre sightings in such a tight span, stirs our instinct for patterns, hinting at ties we haven't grasped. Sure, correlation doesn't equal cause, but it can flag hidden frameworks awaiting discovery. And black holes aren't the sole cosmic scar pulling focus just now. As we've followed these galactic roamers, our sun has sprung a wound. This interference impacts every aspect we're attempting to examine. Now, let's shift focus to the sun and a potential gap that could be clouding our view of the facts. Part 7. The enormous gash on the sun. The sun doesn't present a flawless surface. We often picture it as an ideal orb of nuclear fusion and radiance, steady and reliable, the stellar powerhouse driving our solar setup. Yet, what solar observatories uncover is far more turbulent. The sun's exterior boils with convective currents and twisted magnetic forces. Sunspots emerge and dissipate. Prominences leap tens of thousands of kilometers into the void. And from time to time, the sun develops a fissure. Coronal holes live up to their name. openings in the sun's uppermost layer where magnetic lines fail to curve back to the surface, instead surging straight out into the cosmos. These aren't literal voids devoid of substance, but zones where the plasma runs cooler and thinner compared to the adjacent corona, showing up as shadowy spots in extreme ultraviolet views. Crucially, they serve as escape routes for the solar wind, which ramps up to velocities reaching 800 kilometers per second, hauling along ionized particles and magnetic influences far across the solar domain. In October 2025, monitoring stations spotted a huge coronal hole pointed toward our planet, among the biggest in recent memory. It spanned a large portion of the sun's facing side, a shadowy blemish amid the roiling luminosity, resembling an astral injury that refused to mend. Experts anticipated robust solar wind flows hitting Earth soon after, possibly sparking geomagnetic disturbances, hindering satellite functions, sparking northern lights farther south than usual, and overall stirring up the electromagnetic conditions around our world into greater disorder. For the average person, these coronal holes captivate mostly for the stunning auroras they produce. The onslaught of charged particles from the sun collides with our planet's magnetic shield and air layers, rousing atoms and molecules to glow, draping the heavens in veils of emerald, crimson, and violet. It's a breathtaking spectacle, one of the wildest natural illuminations, pulling in shutterbugs and sightseers to polar regions whenever intense solar bursts are forecast. However, for stargazers aiming to scrutinize dim celestial bodies with precision, solar outbursts turn into a disaster. The surge of particles muddles radio signals, generating static that overwhelms subtle transmissions. Shifts in the magnetic field can hamper satellite maneuvers, possibly blurring photos from space-based scopes. Even Earthbound visual instruments suffer, as heightened ionization high in the atmosphere warps incoming light rays. Whenever the sun bears such an active scar, with coronal holes spewing plasma our way, our capacity to peer sharply into the depths of space takes a hit. Think about the schedule involved. The Atlas comet hit its perihelion, its nearest pass by the sun, on October 30th, 2025. That was prime time for scopes to collect the sharpest insights, with the comet shining brightest, nearest, and easiest to track. And right then, a gigantic coronal hole loomed toward us, precisely when the solar wind peaked in force, when the electromagnetic setup grew most turbulent. Mere chance? Most likely. The sun's rhythms follow their own independent cycles, regardless of visiting asteroids or comets. Coronal holes form through magnetic processes we can't fully master or foresee. The overlap amounts to sheer misfortune, an unlucky clash of viewing opportunities and solar antics. Or could it be more? This is where we must guard against the stories we weave. It's all too simple to spot designs that aren't there, to twist random events into plots, to suspect the cosmos or some force inside it is purposefully syncing events to obscure our gaze. That's probably not the case at all. Still, the consequences hold true no matter the reason. In that vital stretch when Atlas was ideally set for in-depth analysis, our tools functioned amid compromised conditions, battling solar interference to snag readings. Any faint traces, any minor oddities, any delicate features that could clarify the comet's essence, those would prove tougher to detect, simpler to overlook, and more prone to getting lost in the clutter. The imagery proves compelling. A rift in the sun, a laceration on our central star erecting a veil of confusion exactly when we crave sharp focus. It plays out like a suspense novel script, crafted to heighten doubt. And perhaps that's exactly what it boils down to. A happenstance that strikes us as profound because our minds are wired to find intent in chaos. Yet it's also worth noting that if something aimed to traverse a star system incognito, to slip by while staying elusive, it might just schedule its entry amid a spell of intense solar unrest. Engaging in such activity could prove tactically advantageous. The impaired monitoring works in your favor, along with the interference concealing your transmissions and the diminished precision of the devices monitoring your position. Uncertainty poses this challenge. Once immersed in it, any piece of data lends itself to various interpretations. The coronal hole might simply represent solar weather, natural fluctuations in stellar activity. Alternatively, it could serve as a diversion, a disruptive signal aiding something intent on staying vague and elusive. Each interpretation aligns with the evidence, yet neither can be conclusively verified or refuted based on current data. This leaves us navigating that familiar space between certainty and conjecture once more. And the enigmas of the cosmos extend beyond solar voids. As we've observed entities wandering and our sun expelling plasma streams, experts in cosmology have started re-evaluating the grand conclusion for all existence. Will the universe keep expanding indefinitely? Or might it veer toward implosion? Consider how evolving views on the cosmos's endpoint could be coloring our understanding of today's oddities. Part 8. The countdown to contraction begins. The cosmos is broadening. Each observable galaxy drifts farther from its counterparts. The fabric of space itself expands, akin to the skin of a swelling balloon. This stands as established observation since Edwin Hubble's discoveries in the 1920s. Over years of ever more accurate observations, the rate of expansion has been found to quicken, propelled by dark energy, an enigmatic force permeating the universe that exerts a repulsive effect like anti-gravity across vast distances, accelerating the separation of space. Per the prevailing theory, this outward push persists eternally, galaxies retreating until they slip past our observable limit, stars extinguishing sequentially, the cosmos cooling into darkness, vast emptiness, and an eventual heat death unfolding over trillions and trillions of years. That view has dominated, a somewhat reassuring dread, perhaps, an outcome so remote and detached that it scarcely feels ominous. We possess vast stretches of time beyond imagination. No matter what befalls humanity, Earth, or our slice of the galaxy, the universe endures for ages. But starting in 2025, select cosmological studies challenge this outlook. Fresh examinations of dark energy's properties, faint trends in cosmic microwave background readings, and updated simulations of the expansion's historical shifts all suggested a scenario long deemed improbable. Suppose dark energy doesn't remain steady? Imagine it diminishing, altering its nature, or undergoing a transformation that reverses expansion into shrinkage. What if the cosmos's future isn't thermal demise, but the Big Crunch, a total gravitational implosion drawing all back into unity? Galaxies smashing together, space folding inward, all matter and energy compressed to a single point, mirroring the Big Bang in reverse. These studies were cautious, laden with caveats, emphasizing that proof remained elusive. Eternal growth still held the edge in likelihood. Still, the chance of reversal, previously near nil, now carried a slim yet meaningful weight, perhaps 1%, or even 5%, sufficient to compel respected astronomers to model it, simulate outcomes, and identify potential signs that could validate or debunk the idea. Why is this relevant to probing Atlas? Cosmological tales mold our lens on immediate occurrences. When the universe's trajectory seems fixed, when the overarching plot feels secure, peculiarities get fitted neatly into that reliable structure. This comet seems peculiar, yet the cosmos holds steady. Thus, the oddity must fit our current paradigms. But if the cosmic tale unravels, if the finale shifts, then instability creeps in everywhere. Should we have misjudged the universe's endgame? What other errors lurk? With the foundation wobbling, those peculiarities might warrant deeper scrutiny than before. There's a mental layer too. Tales of impending doom, forecasts of universal conclusions, often surge amid societal unease or conceptual upheavals. In plague-ravaged and turbulent medieval Europe, apocalyptic visions proliferated. The Cold War birthed myriad visions of atomic devastation and civilization's fall. Today, amid ecological turmoil, geopolitical unrest, and swift tech evolution, fascination with doomsday prospects, whether imminent or distant, revives. The Big Crunch aligns with this trend. It offers a universal reboot, a finale doubling as Genesis, a squeeze that could spark another Big Bang and fresh cosmos. Psychologically, it appeals where heat death falls flat. Thermal end is mere entropy's triumph, all gradually fading to oblivion. The crunch suggests intent, renewal, the chance that universes emerge, perish, and rebirth, revived in an endless cycle. It's like ancient myths wrapped in the garb of equations. And it taps into a profound aspect of our psyche that yearns for order and purpose in reality, something more than mere entropy. That's why research emerges proposing that the cosmos could contract instead of stretching out indefinitely. They're not merely delivering arid scientific findings. They're crafting an alternative story, a fresh perspective on the universe's ultimate fate. Such a story conditions us to view current happenings through a specific viewpoint. If the entire cosmos is destined for contraction, for pulling back all that's scattered outward, perhaps extraterrestrial travelers like Atlas aren't mere drifters, but elements of a grander design, some interstellar dance we haven't deciphered yet. Clearly, this ventures into conjecture. The link between cosmic theories and spacefaring bodies is shaky at most, yet stories don't need ironclad logic to wield emotional sway. Once you embrace the idea of the universe marching toward profound change, you begin spotting indicators of that shift all around. Each oddity turns into a harbinger. Every enigma morphs into a hint. The perspective alters, and along with it, how you perceive every detail inside that frame. Here's the awkward reality. Researchers are people too. They aren't shielded from the pull of storytelling. When society fixates on conclusions and upheavals, when theories about the cosmos waver, when established truths face scrutiny, that vibe seeps into how experts analyze their results, which ideas they deem credible, which irregularities warrant scrutiny over rejection. Research isn't some flawless, detached mechanism free from mental quirks. It's an endeavor by individuals burdened with personal leanings and innate urges for tales. Those urges naturally shape the outcomes. Thus, those contraction studies, no matter their final accuracy, reshape the context for analysis. They smooth the path for bold ideas, for pondering vast cosmic scenarios, for questioning whether the peculiarities we observe tie into bigger schemes. They offer no proof regarding Atlas, but they transform the setting in which Atlas gets examined. And at times, that setting holds as much weight as the data itself. Yet let's shift attention from universal endings to nearer-term issues. As stargazers argue over the cosmos's endgame, a more mundane yet equally troubling development unfolds in our near-Earth realm. Spacecraft are plummeting routinely, silently, and their fiery downfall could be concealing key details. Chapter 9. Starlink's subtle cascade of flames. Each day, overhead in the sky, a spacecraft expires. Not figuratively, but for real. Alloys, chips, and photovoltaic arrays scorching to extreme temperatures as they plunge into our planet's upper layers, eroding, fragmenting, scattering as tiny particles or sometimes bigger chunks that endure to strike the ground. A Smithsonian space scientist lately calculated that 1 or 2 Starlink craft disintegrate or re-enter daily. Not every few weeks, every single day. That equates to hundreds of items annually from one enormous satellite array turning to vapor on their way down. The cause boils down to basic mechanics. Low Earth trajectories aren't vacant. Lingering air persists even at heights of hundreds of kilometers, sufficient to generate slight friction against spacecraft. Gradually, that friction decelerates them, dropping their paths until they enter thicker air and can no longer hold position. Decay in orbit is unavoidable. Any launch device will plummet eventually unless repeatedly propelled to sustain its course. For compact craft lacking ample propellant, the service span could span just a handful of years before drag forces initiate their terminal drop. Starlink, Elon Musk's SpaceX effort to deliver worldwide web access, features thousands of units in low paths. The blueprint envisions tens of thousands in total, forming a grid so thick that from anywhere on the globe, several are in sight past the skyline. This demands functioning in low paths where air resistance matters a lot, so units get swapped out periodically as they deteriorate and incinerate. That's the origin of the daily blaze shower, a constant flow of fading equipment evaporating above us, largely overlooked since each incident is minor and frequent enough to skip headlines. But consider its impact on the viewing landscape. It introduces noise. Countless spacecraft bouncing back light, disrupting scope views, generating lines in celestial photos that require digital cleanup. It boosts mistaken identifications, fleeting blips in aerial scans that prove to be spacecraft or wreckage instead of space rocks or icy visitors. It complicates the challenging job of monitoring petite bodies across the void. It becomes even more challenging to separate authentic cosmic events from the expanding swarm of human-engineered devices crowding the space around our planet. For those attempting to examine entities like Atlas, this becomes crucial during the scrutiny of dim features, when detecting minor shifts in luminosity or path. Confirming if a sighting is legitimate or merely an illusion grows tougher with countless man-made items invading the observational area. Any enigmatic pulse might stem from a spacecraft, any odd gleam from fragments reflecting light in an unexpected way. The baseline interference escalates, heightening the challenge of isolating true indicators amid the clutter. There's also a more hypothetical angle to explore. Could the surge in orbital operations offer concealment for spotting or concealing unusual occurrences? If the goal were to monitor our world undetected or to traverse nearby orbits while preserving ambiguity, merging with the multitude of existing synthetic debris would prove a clever tactic. Observatories spotting you might dismiss you as yet another orbiter, additional junk, or simply another element in the escalating mess that experts have grown accustomed to ignoring. This disguise isn't intentional on your end. It's courtesy of our own engineering feats, the network of devices we've enveloped ourselves in. This ties into a larger notion of clarity versus chaos, where escalating intricacy clouds our vision. As we deploy more probes into space, stargazing gets tougher. With accumulating orbital waste, separating noteworthy sightings from trivial ones proves increasingly arduous. We're generating our own veil, encircling ourselves in a tech-induced mist that veils the very stars we aim to explore. And whatever seeks to stay concealed, vague, or overlooked thrives in that obscurity. The paradox runs deep. We send up these craft to enhance connectivity and surveillance, equipping us with superior means to probe the cosmos. Yet this very action tarnishes the setting for those pursuits, complicating the detection of subtle entities, the monitoring of irregularities, the judgment of whether a finding holds weight or is just stray equipment glinting as it re-enters. Advancement breeds its own barriers. As our innovations advance, they increasingly sabotage one another. Solutions aren't straightforward. These orbiters fulfill essential roles that society prizes: global web links, climate tracking, vital networks, all hinging on that satellite array. Advocating for fewer launches equates to forfeiting tools and benefits that support countless lives. Thus, the array expands, the mess multiplies, and the clarity for observations keeps eroding. That's our current path. Without a dramatic regulatory change or innovative fix, we'll remain locked in it. This leads to the most baffling element of the Atlas narrative: the quietude, the voids and updates. The impression that bodies meant to disseminate details are withholding them. Why do officials stay mute amid strange developments? What drives the restraint or apprehension in partial revelations? Let's probe that reticence and its potential insights. Part 10. The hush preceding revelation. Quietude conveys data when anticipation builds for updates that never arrive. When groups accustomed to steady outreach abruptly still. When the lack of declaration stands out more than any issued ones, it sends a message, albeit an inverted sort. The reticence surrounding Atlas, the intervals between detections and bulletins, the meticulous screening of each outward message, all transmit intent, though its precise nature eludes us. Orbital organizations function within limits few consider. Publicly shared visuals undergo scrutiny, adjustment, validation. Remarks on findings must be exact, supportable, resistant to later refutation. This isn't suppression or plot. It's the standard prudence of entities whose trust rests on reliability. Should NASA herald a breakthrough proven false by glitch or oversight, the blow to their standing could linger painfully. Hence, they verify, re-verify, holding off on announcements until assurance solidifies. This breeds a time-frame lag, a pause from detection to disclosure often spanning weeks or months. For standard scans, it's negligible. So what if a report on a remote stellar cluster lags 6 months post-capture? That formation remains fixed. But for fleeting incidents, for entities streaking by objects in our solar system zip by on timelines spanning mere days or weeks, turning even modest delays into major hurdles. When the space agency finally gears up to issue an update, the incident is usually over, the item has drifted away, and folks are left scratching their heads about the lack of timely notice. This trend shows up repeatedly in various late-breaking cases. Discoveries of fresh exoplanets via gravitational waves or transit techniques frequently linger unannounced for months. Captivating radio signals picked up by telescopes undergo thorough internal checks before word leaks to anyone beyond the core team. Odd snapshots from orbiting probes pass through elaborate review and refinement stages that might stretch a full year or longer prior to going public. Such protocols are par for the course, not tied to Atlas or any single project. Yet, when the findings could be groundbreaking, this routine holds back hits differently. Whenever the lag touches on info that might resolve big cosmic riddles about humanity's spot in the cosmos, and the space between spotting and spilling it fuels rumors and rival tales, that everyday prudence begins to seem suspicious. It begins to resemble intentional hoarding, narrative steering, or an organization calling the shots on public access to knowledge. Here's where the system's built-in motivations stir up trouble. Organizations aim to shape their own stories. They prefer dropping news on their timetable, in their phrasing, under their spin. Unauthorized drips are a no-go. Early drops risk embarrassment. Unchecked hype prior to confirmation? Disaster. From the outfit's viewpoint, this logic holds water, but to everyday observers, it screams cover-up. It evokes choices hashed out in secret about what's fit for wide release. And that vibe, true or not, erodes confidence. History offers clear examples of outfits holding back or soft-pedaling weird results at first. The iconic Martian face, snapped by the Viking orbiter in 1976, debuted in a media alert highlighting its man-made vibe, only for follow-ups to clarify how shadows and pixel limits warp perceptions. The 1977 WOW signal, nabbed by SETI folks, stayed under wraps in public chats for years, even as it ranked among the top radio curiosities. The flickering of Tabby's star, once buzzed as possibly an extraterrestrial megastructure, sat in researchers' notebooks long before hitting open data streams. In every scenario, solid reasons justified the hold-up. Experts needed to nix gadget glitches. They sought extra evidence. They shunned bold assertions without solid backing. Still, the fallout mirrored. Crowds caught wind of these game-changing sightings way after the fact, via routes that smacked more of spin control than forthright science sharing. Each episode cemented the notion that establishments were playing info bouncer, sorting which inquiries merited open debate and which stayed locked in elite huddles. Now, layer that onto Atlas. The thing popped up in July. We're into late October now. A smattering of pics has surfaced, mainly blurry specks or trails. Official bulletins keep hammering the comet theory as routine, brushing off oddities, and insisting all's as predicted. No sharp, detailed shots from gear primed for them. No raw spectral readings for outside pros to double-check the make-up assertions. We're urged to buy that the groups probing Atlas are laying all key cards on the table, even as their track record hints at selective sharing. This breeds what's dubbed the quiet interval, the span from detection to reveal where story shaping unfolds. In that stretch, the body calls the tune. They pick what shines and what hides in jargon-filled addendums. They mold the find and the wording that guides public take, all hashed out in unseen strategy sessions and vetting rounds. When the sanctioned version drops, the tale's already built, the slant set, the bounds of guesswork drawn. Conspiracy in the tinfoil hat way, with evil plots? Hardly. But it's steering info, curating plots, safeguarding the org's skin, and it paves the way for wild theories to bloom. After all, when the masses sense the complete picture's missing, they patch the holes with flashier, flimsier yarns than an upfront truth might offer. Atlas anchors it all. We're dealing with a bunch of bizarre cosmic signals here. Several odd phenomena in space that might connect or might not. Wandering black holes drifting through the galaxy unchecked. Gaps in the sun's surface messing up our readings. Theories about the universe shifting unpredictably. Spacecraft tumbling down like they're caught in a storm. Any one of these could just be isolated incidents without links between them. Or perhaps they're fragments of a bigger picture that's hidden because the information is all over the place. The announcements are held back. The story gets chopped up by official hesitancy and controlled messaging. What stands out is that something from a distant star system is currently crossing our own, showing traits that question our understandings, and the organizations examining it are selective about their disclosures and timing. That quiet could signify zilch, or it could signal a lot. We can't tell until the chance passes, until the facts come out, until we get to examine for ourselves just what this atlas thing really amounts to. For now, we're stuck with blanks and hunches, gazing at the heavens and pondering what's spotted but kept under wraps. And on that note about the heavens, let's turn to the schedule of events. Because amid all this oddity, heavenly occurrences keep pressing on according to the rules of gravity and stellar clocks. These happenings, these wonders, could serve as diversions or as chances to notice something. They might obscure key details or uncover what's concealed. Regardless, they're approaching. Pencil them in. The performance is gearing up to start. Part 11. The frosty full moon ascends on December 4th. The moon goes by various titles drawn from societies that used its cycles as guides for time and seasons. This full frosty moon will peak on December 4th, 2025. The term comes from early American settlers who drew on native customs linking this moon to the start of harsh winter, chilly evenings, iced earth, the year nearing its bleakest moment before the solstice hints at light's comeback. Full moons have a raw, instinctual pull. They've shaped people's actions since our earliest days, signaling seasons for pursuits like foraging, sowing, ceremonies, and feasts. Folks today often claim they've outgrown such pulls, that artificial glow and electronic planners have liberated us from the moon's sway. Yet ERs and hospitals still log more bustle on full moon nights. Cops observe shifts in their incident reports. Research on rest reveals tangible impacts on our internal clocks, even if folks indoors miss the sight. Deep down, we're creatures still swayed by those primal pulses our forebears adapted to. No matter how we deny it, the frosty moon will shine worldwide, conditions allowing, emerging in the east as daylight fades westward, reaching its zenith near midnight, casting that eerie, pale glow over the terrain, intense enough for perusing a page, yet dim enough to wash out hues. It's a threshold radiance, bridging light and shadow, turning the everyday eerie and unveiling the obscure. Purely from an astronomy angle, this full moon's nothing special. No supermoon status, no extra proximity, size, or luminosity. Just the moon doing its routine lap, bouncing back another sliver of solar rays to us. Yet on a deeper level, cultural, emblematic, mental, it carries weight. Crowds will step out to gaze. Snappers will frame it against horizons and urban sprawls. Feeds online will overflow with lunar shots, each unique in its angle, each striving to snag that elusive vibe of lingering beneath its beams, struck by feelings of insignificance, unity, and timelessness all together. Now, layer on some conjecture. Suppose oddities like Atlas align by design or chance with times when eyes are drawn away. A full moon acts as a stellar beacon, pulling countless gazes skyward. With focus on the moon, other sights fade. With scopes aimed lunar or battling its glare that overwhelms subtle targets, they're not scouting quirks elsewhere overhead. Essentially, the moon forges a gap in vigilance, a shared fixation that might veil concurrent happenings. This doesn't imply some interstellar plot where extraterrestrials sync flybys to moon schedules. That's ridiculous. But it does highlight how pinpointed focus leaves openings elsewhere. Illusionists live by it. Slight relies on diversion. Fix the crowd on one side, and the other slips by unnoticed. Fix them on the moon, and subtler motions in the shadowed expanse go overlooked. The frosty moon bears metaphorical heft too, shaping our reads of nearby occurrences. Frost evokes wrapping up, stillness, a phase's close. December brings retreat, halting expansion, a turn to introspection. If peculiar happenings bunch up near this timing plays a crucial role. If revelations or findings emerge in early December, they'll be viewed through that metaphorical prism, focusing on conclusions instead of starts, finality over fresh starts. The storyline alters depending on revelation moments, even when the schedule is merely happenstance. And it might well be just that. Perhaps lunar cycles and cosmic travelers bear no relation whatsoever. Perhaps the frosty moon is simply the moon, and Atlas is merely transiting, with any links between them stemming from spotting patterns in chance events. Yet humans are natural tale weavers. We instinctively weave stories from occurrences, links from flukes, significance from schedules. As the moon ascends, the traveler glides by, and in their intersection, we craft a tale that resonates with us, regardless of the cosmos's indifference. The key is to recognize your own observations. When the frosty moon emerges, when your gaze lifts to the heavens, ponder what else is unfolding, what additional entities are traversing the void, what information is surfacing or suppressed, what declarations are issued or postponed. The moon captivates with its allure, deserving of observation, snapshots, and admiration. Yet avoid letting its splendor obscure the broader celestial panorama. At times, a display is merely a display, while other times it masks elements that might otherwise catch your eye. On that note of displays, the frosty moon serves as merely the prelude. A supermoon looms ahead, grander and more luminous, certain to seize front-page spots and online buzz. Let's explore how the most striking lunar spectacle of 2025 could influence our perceptions and oversights. Part 12. The Supermoon of 2025. Early November. A supermoon evokes excitement, reminiscent of superhero tales or catastrophe films. In truth, it's subtler, yet undeniably striking. It happens when the full moon aligns with perigee, the moon's orbital closest approach to our planet in its oval path. The moon doesn't follow a round trajectory. It's elliptical, so at intervals, it's roughly 50,000 kilometers more distant from Earth than usual. Should fullness strike at perigee, it seems about 14% bigger and 30% more radiant than at apogee, the remotest position. That's sufficient for the naked eye to detect, particularly as the supermoon climbs near the horizon, where air layers amplify its size via a visual trick. The largest supermoon of 2025 hits in early November, likely the third or fourth, based on precise perigee timing versus peak fullness. For everyday viewers, the fine points are irrelevant. What's vital is that over a handful of evenings, the moon will command the darkness, luminous enough to etch deep shadows, stunning enough to halt passers-by, compelling enough to spark a shared cultural phenomenon beyond mere science. And that's precisely what intrigues us here. Supermoon events spark widespread involvement. They offer easy entry to stargazing, needing only eyesight and interest. Media highlights them. Weather reports nod to them. Online platforms flood with images snapped from diverse spots and perspectives. For those evenings, countless folks who rarely ponder orbital dynamics turn into impromptu lunar enthusiasts, venturing out to peer upward, posting their views, joining a communal skyward ritual. This is truly enriching. Whatever draws folks toward the stars, prompts them to gaze and question, ties them to the vast universe past daily worries. That boosts society overall. But it also diverts focus en masse. With all eyes on the moon, with scopes overwhelmed by its glare, with discourse saturated by supermoon visuals, subtler happenings can slip by undetected. Atlas reaches its nearest to Earth in late October, right ahead of the November supermoon. This alignment ensures that as Atlas navigates its prime viewing window, societal focus pivots to a lunar extravaganza. Experts in astronomy will continue monitoring Atlas. Naturally, they aren't swayed by scenic moons, but general awareness, press spotlight, and wider space dialogues all gravitate to the more approachable, flashier occurrence. Atlas fades to mere undertone, if acknowledged, eclipsed by the supermoon's popular draw. A recurring historical trend merits attention. Significant updates often drop amid divided focus. Officials unveil tough regulations on late Friday afternoons preceding long breaks. Companies disclose grim earnings post-trading hours. It's rarely a plot. More often, it's savvy messaging, selecting slots that soften backlash or give space for digestion. Without facing sharp public examination right away. Might the very same tactic extend to oddities in space? Could the choice to reveal or withhold info tied to big astronomical occurrences be an intentional move to shape how people react? It's possible. Or perhaps the schedules truly align by chance. Simply the outcome of planetary paths and viewing opportunities, unrelated to any plan for sharing news. Yet the impact persists. As the supermoon takes center stage and talks about the cosmos, quirks like Atlas slip quietly aside. Inquiries that would demand attention amid calmer headlines end up whispered or overlooked entirely, overshadowed by the thrill of the supermoon. And consider the mental side of it. Supermoons hold a peculiar comfort. They're reliable, anticipated, woven into the steady cycle of sky movements. They serve as a reminder that certain aspects of the cosmos stay reliable, that paths around planets obey clear principles, that we can forecast and ready ourselves for these moments with total precision. Amid eras of stellar doubt, with tales of alien craft, wandering voids, and end-of-world theories buzzing in expert circles, the supermoon brings solace. See, it whispers, the cosmos operates as taught in your lessons. The moon circles our world. Closest and farthest points arrive right on time. Not all is bizarre. This sense of security, this nod to the known, could be precisely the mental balm folks crave, or it might block them from tackling truly odd happenings. When comfort arrives, when a dazzling display offers a simple distraction, it's easy to embrace it and sideline the tougher, more disturbing puzzles just beyond the glow. The supermoon captivates with its allure, yet allure can ensnare. It holds your gaze fixed one way while other paths go uncharted. So as the supermoon climbs in November, as the heavens fill with that swollen, glowing orb, don't forget to scan beyond it. Spot other sights in view. Wonder what info flows out or stays hidden. Observe if updates drop amid the supermoon buzz or get time to follow once the show fades. The moon merits a glance, but it ought not claim all focus. The heavens stretch wider than their shiniest feature, and at times, the key events unfold in those shadowy zones we prefer to skip. On that note of trails cutting the night, the supermoon isn't the sole sky spectacle lined up soon. Meteor displays loom ahead, yearly spectacles that streak the firmament with flames, each with their methods of seizing eyes, and maybe masking what merits our notice. Let's shift to the southern Taurids and the scene when the air above ignites with luminous trails. Part 13. Flames above. The southern Taurids. Each year come early November, our planet's path guides us into a trail of remnants from Comet Encke, a brief orbit comet that loops the sun's inner realm every 3 years. The fragments create a flow of bits aligned with the comet's route. When Earth crosses that flow, the bits collide with our air layer at roughly 30 kilometers per second. Heat from resistance glows them white-hot. They burn up in vivid lines. We term it a meteor display, in this case the southern Taurids, so called since the streaks seem to burst from Taurus. The southern Taurids lack the grandest flare among showers. Top counts usually hit just 5 to 10 per hour, tame beside bursts like the Perseids or Geminids, which unleash scores or hundreds hourly at their height. Still, Taurids earn praise from sky watchers for spawning fireballs, exceptionally vivid streaks that momentarily eclipse top stars, sometimes trailing enduring wisps of charged, shining vapor that hangs seconds beyond the streak's fade. The event runs from late September to late November, cresting around early November, syncing with the supermoon phase we mentioned. Thus, in that span of extra lunar glow drawing eyes upward, the vault overhead also sparks with meteors, everyday pyrotechnics that heighten the drama and amplify the feeling of bustling activity overhead. Viewed one way, this is mere happenstance. Our world circuit is set. Comet Encke's fragment trail sits fixed. The moon's nearest approach falls as it does. These are separate forces shaped by poles of gravity, indifferent to our watching or spin. The shared timing just means the universe multitasks in the skies at once. Seen another way, the convergence breeds clutter. When seeking particular items amid the void, when hunting irregularities or atypical courses, a heaven packed with observing during peak meteor activity makes the job even tougher. Each flash across the sky needs careful scrutiny. Is it a Taurid? A satellite glinting? Space junk tumbling? Or perhaps something entirely different? As more ordinary cosmic events unfold, it gets increasingly difficult to separate the true outliers from the routine backdrop, the real oddities from the anticipated displays. And consider this intriguing hypothetical. Might bits of interstellar visitors get mistaken for ordinary shooting stars? Comet Atlas is venting gases, releasing chunks of itself as it journeys through our solar system. This ejected stuff creates a trail, a hazy swarm of particles trailing the comet's path. Should Earth cross that dusty path someday, if extraterrestrial fragments plunged into our air, would we spot them as separate from the regular meteor displays we anticipate? Or would we chalk them up simply as extra bits from the Taurids, more remnants of Comet Encke, and never bother digging deeper? The makeup ought to give it away. Analyzing a meteor's light spectrum can pinpoint its ingredients, and material from beyond our system should display unique chemical markers unlike those in local comets, provided, of course, that an observer snags a reading from that exact streak, that the capture occurs in those fleeting moments of visibility, that an anomaly stands out enough to prompt a thorough probe. For most fireballs, though, we catch a glimpse, snap a pic perhaps, and that's it. In-depth spectral studies are reserved for the standout or heavily documented ones. This leads to a kind of camouflage through commonality. Intense meteor periods offer a veil of normalcy, a bustle of foreseen happenings that could conceal the unforeseen. If an entity aimed to probe Earth discreetly, if it were dispersing particles that could drift into our atmosphere, sinking that release with a big meteor display would be a clever move. Your cast-offs mingle with the usual litter. Your traces dissolve into the familiar buzz, and skywatchers, primed for the standard spectacle, label it all as business as usual without a second glance. Pure conjecture, to be sure. Nothing indicates Atlas debris is infiltrating our skies. No signs point to hidden quirks amid the Taurids. Yet the setup allows for it. The conceptual gap where mix-ups might slip through. And highlighting that gap matters, since it tempers our certainty in declaring what we've truly spotted. Plus, meteor showers pull gazes skyward. Much like a supermoon or any stellar showstopper, they channel focus to particular spots at set times. Folks venturing out to catch Taurid fireballs connect with the heavens in ways they rarely do. They're alert, gesturing at streaks, clicking shots, but zeroed in on the meteors, the planned pageant. Meanwhile, other sky wanderers could drift by as overlooked extras in the main act. The Taurids hold some lore among stargazers too. Certain experts propose that the Taurid swarm, the wide band of rubble tied to Comet Encke, harbors bigger chunks, rocks spanning kilometers that could threaten Earth with strikes. Such ideas spark debate and lack broad support, but they infuse a subtle edge of peril into an otherwise enchanting yearly ritual. Gazing at Taurid streaks means admiring harmless specks. Still, lurking in your thoughts might be the worry. Is a heftier piece lurking in that same trail, maybe barreling toward us? Atlas doesn't belong to the Taurid group. Its roots lie fully in interstellar realms, unlinked to Comet Encke. But the mental link, the tie between overhead wonders and lurking risks, shapes a mindset where strange sights get viewed as perils. The Taurids underscore space's perils. Atlas, inbound from the void with its quirky traits, fits neatly into that risk narrative, despite zero chance of impact. The stories overlap not from shared truths, but from stirring parallel instincts. Thus, as the southern Taurids crest in early November, as the heavens ignite with trails and bursts, tune in beyond just the meteors. Watch for reports of odd movers that get brushed off. Ponder if the blending of patterns is mere chance or cleverly timed. The Taurids merit your stare. They're an authentic cosmic marvel, a nudge that our world sits within a lively cosmos of endless flux. Yet resist letting the routine dazzle obscure, subtler surprises unfolding elsewhere overhead. And the Taurids kick off the sequence. A flurry of starry explosions awaits, illuminating the night from November into December. Let's delve into how this unfolds. The grouping of celestial spectacles could be influencing our perceptions, obscuring what lurks in the gaps amid those luminous trails. Part 14. A flurry of Leonids, Geminids, and Ursid showers. The heavens in late 2025 promise plenty of action, beyond just Atlas, beyond supermoons and coronal openings, featuring a steady lineup of meteor displays. 3 prominent spectacles unfolding in rapid sequence, as if orchestrated by the cosmos for a seamless show. The Leonids peak on November 17th and 18th. Remnants from Comet Tempel-Tuttle generate meteors seeming to emanate from the Leo constellation. Renowned for sporadically unleashing meteor storms, episodes where thousands of streaks light up the night per hour, though such outbursts occur only in certain years when our planet traverses especially thick parts of the debris trail. 2025 won't bring a storm. Expect a tame showing from the Leonids, perhaps 10 to 15 meteors hourly at maximum, best viewed in the early morning when Leo climbs highest. Next up, the Geminids on December 13th and 14th, widely regarded as the year's most dependable and striking meteor event. Unlike most, the Geminids stem from an asteroid rather than a comet. 32,000 Phaeton, possibly a dormant comet that lost its icy layers, leaving just the stony nucleus. At their height, Geminids can deliver up to 120 meteors per hour. Vibrant, multicolored flashes observable from any spot on the globe, assuming clear skies. They offer a consistently dazzling spectacle, one that often makes headlines and lures folks outdoors despite the December chill. Wrapping things up, the Ursids on December 21st and 22nd, originating in the Ursa Minor constellation, sourced from Comet Tuttle. These are usually meager, around 5 to 10 meteors per hour, and hampered by bad luck and timing. Cresting near the winter solstice, when northern nights stretch longest but clouds frequently spoil the view. They serve as the subdued finale to the annual meteor roster. Not as grand as the Geminids, yet a steady December fixture nonetheless. Spanning 3 key showers over 5 weeks, coinciding with Atlas's trek through the solar system's core, aligning with the supermoon, and syncing with heightened solar flares from that coronal feature. If crafting an era of peak heavenly hustle, peak atmospheric buzz, peak incentives for eyes and telescopes to tilt skyward, you'd be hard-pressed to time it more ideally. The cosmos has gifted us a thrilling fall and early winter, a stretch brimming with stellar wonders to captivate stargazers and experts alike for months on end. Yet this alignment sparks intriguing dilemmas. When meteor events bunch up, when the firmament fills with anticipated wonders, the watching conditions grow intricate. Any unidentified item must stand out against the familiar clutter. Each odd sighting vies for focus amid dazzling yet understandable happenings. Meteors dazzle, merit observation, hold their own scientific value. Still, from the angle of monitoring other entities, they add clutter, a constant hum that rarer signals must surpass to register. Might interstellar debris, haze trailing Atlas's path, bits ejected as it navigates our system, align with these routine showers? Could extrasolar stuff be plunging into our atmosphere currently, incinerating beside Leonid or Geminid fragments, overlooked or wrongly tagged, because we anticipate meteors in these slots, and perception follows expectation? Close chemical scrutiny would expose the reality. But we don't spectrum analyze every fireball. We skip in-depth probes on most streaks. Vastly more meteors get mere glimpses, snaps maybe, and nothing further. Just a sliver receive the rigorous study needed to spot quirky makeup. Thus, if alien matter blends with local rubble, if oddball flecks camouflage within the norm, spotting them demands something glaringly offbeat, wildly peculiar, defying easy labels. Factor in the psychological side too. Once sky happenings embed in our schedules, once they're forecasted, hyped, and routine, they fade into the everyday tapestry. Geminids strike each December. Leonids hit every November. These are certainties, as routine as the turning seasons. No enigmas here. No outliers. Just the steady beat of our orbital path sweeping through comet and asteroid leftovers. This familiarity serves a purpose. It enables forecasting and readiness. It facilitates planned viewings and community events. It transforms wild space antics into graspable rhythms. But all this leads to overlooked areas. Once something becomes routine, we cease to probe it. We lose the ability to view it anew. We categorize, store away, and proceed. If a truly odd occurrence lurks inside that familiar routine, we could easily bypass it altogether, since we've conditioned ourselves against scrutinizing what we assume we grasp. The bunching of these meteor displays near Atlas's trajectory might simply be chance. The rules of orbital physics disregard our stories. Our planet's route via diverse debris fields follows gravity's dictates, unaffected by whatever extraterrestrial visitors coincide with them. Nothing suggests the schedule holds purpose or intent. Yet, schedules shape surroundings. When big headlines erupt amid diversions, they draw minimal notice. When key shifts arise as crowds fixate on other matters, they risk being ignored or downplayed. That dynamic could extend to the stars. Amid skies packed with anticipated displays, like meteor storms, supermoons, and routine wonders. Oddities can slip by with scant examination compared to calmer times. No intent is needed here. No plot or alliance required. It's merely the outcome of limited focus, of finite nighttime hours, limited scopes aimed skyward, and bounded capacity for sifting data. In busy times, not all receives equal scrutiny. Choices emerge, efforts direct, and certain items, possibly crucial ones, drop to lesser slots, just because they vie with flashier or more pressing spectacles. Thus, as the Leonids flash, the Geminids flare, and the Ursids wrap the year, keep in mind you're viewing a selected spectacle, not shaped by any person's touch, but shaped by the bounds of notice and survey. What catches your gaze is the most vivid, evident, anticipated. What evades it could hold greater weight, concealed in the shadows amid the trails, gliding overhead as your sight follows the bursts. This leads to the core query we've orbited in this probe. Do all these stellar happenings, these moons, meteors, voids, and quirks, amount to mere alignment, mere fluke, the cosmos humming in disjointed fashions at once? Or does a broader force stir? Some design we overlook due to our proximity. Let's pull away and scrutinize the timeline outright, wondering if we're amid a ticking toward an unnamed event. Part 15. Timeline or timer. Consider our gathered elements. An extraterrestrial body with quirky traits traversing our system. A wandering black hole roaming the Milky Way. A vast solar void scrambling sun watches. Research hinting the cosmos could collapse instead of stretching eternally. Orbiters plummeting routinely, stirring visual clutter. A supermoon seizing crowd focus. 3 prime meteor events packed into 5 weeks. The cold moon ascending, laden with its emblematic sense of finales and wrap-up. Viewed alone, each makes sense, routine, foreseen, or hardly startling. The cosmos sprawls and stirs, with oddities routine. Spotting several oddities aligning shouldn't shock. The field is immense. The pool of noteworthy stellar shifts is endless. Some pile-up is bound to occur. Yet the overlap prods at minds wired for designs. These aren't scattered odds dotted over years. They're bunched, focused in a slim span from late October to December 2025. And each, in its manner, hampers either our clear sight or our watchfulness. The solar void hampers gear. The supermoon grabs focus. The meteor events spawn static. The orbiters pile debris. Atlas threads through, elusive and offbeat. Spotted, yet blurred. Probed, yet unresolved. Thus, 3 lenses for decoding our scene. 3 paths to grasp the display. First, sheer chance. The cosmos ignores human gaze or spin. These are standalone occurrences that align by random whim, as chance yields bunches. Flukes arise. Spotting links here is mere apophenia, the urge to find sense in chaos. This stands as the most secure view. No stretched logic, no wild theory needed. It's likely accurate. Second lens, story shielding. Not scheme, but an inherent setup where real quirks gain cover by aligning with eras of intents amid the clamor and diversions of multiple celestial happenings, something like Atlas, an outlier that might draw sharp attention in calmer times, slips by more easily during this era of grand displays. This isn't due to any orchestrated scheme, but rather the overcrowded sky-watching scene, which complicates pinpointing, verifying, and prompts brushing aside or postponing deeper review. In this perspective, the schedule needn't be intentional to carry weight. The outcome persists irrespective of purpose. The third viewpoint, celestial orchestration, ventures into the realm of conjecture, tough to substantiate yet compelling to explore. Suppose these occurrences intertwine in ways beyond our grasp. Imagine Atlas fitting into a broader tapestry, an overarching dynamic influencing various cosmic facets all at once. We've treated them as isolated incidents unfolding side by side. Yet, what if they're intertwined? What if wandering black holes, wandering interstellar bodies, solar flares, and even meteor trails connect via undiscovered forces? Here, we're not confronting mere chance, but a design whose rationale eludes us for want of the right conceptual tools to discern it. Each lens offers merits and pitfalls. The chance lens proves economical yet risks overlooking true oddities. The concealment lens credits systemic influences sans motive, though it could inflate ordinary fluctuations. The orchestration lens sparks the mind, yet craves proof that's absent and unlikely to emerge. Deciding among them demands balancing not only evidence, but deeper convictions on the cosmos's nature, its concealed designs, or if happenstance ever suffices as explanation. Undeniably, the star-studded agenda for late 2025 brims with an exceptional array of spectacles. Be it haphazard bounty or purposeful alignment, whether the pace boosts or blocks revelations, whether this is routine stellar fare or portentous shift, these puzzles defy resolution with present insights. We linger in ambiguity, gazing heavenward, monitoring the timeline, pondering if it's merely marking days or ticking toward revelation. And one last disquieting notion, perhaps the inquiry matters most. Perhaps the crux lies not in Atlas's origin, natural or crafted, nor in the alignment's randomness or staging, nor in extraordinary sighting versus mundane misread through our aspirations and dreads. Perhaps it's vital that we pose these queries, that we crane our necks skyward, that we wrestle doubt instead of fleeing to unshakable assurance. The tale weaving around Atlas, the account we're weaving of its essence and import, mirrors our own nature as much as the thing itself. It exposes our dance with vagueness. Do we leap to verdicts or dwell in ignorance? Do we lean on authorities or probe them? Are we game for uneasy what-ifs? Or do we crave a predictable cosmos to soothe our psyches? So, tilt your head up, observe the pale lunar ascent, tally the shooting stars as they dash. Mark the supermoon's glow and the shadows encircling it. Follow Atlas's traverse of our solar realm before it fades into the starry expanse. Yet turn gaze inward too. Spot the beliefs you crave and their roots. Detect what unsettles you and what that unease shields. Acknowledge the tales you spin about the heavens' drama, seeing them as human fabrications draped upon realities that stand apart from our views. The timetable marches on. The timer, should one tick, advances on rhythms beyond our sway. Occurrences will play out. Findings will surface or stay sealed. Inquiries will resolve or morph into fresh ones. And will persist in observation, speculation, story spinning. Human essence when mystery beckons. Who scripted this lineup? The bunching of stellar episodes in these precise months? Did a mind behind it all? Or does that probe miscast intent onto bare happenings? The cosmos authors nothing. It schemes not. It evolves per principles we half comprehend, yielding motifs that mimic intent but may stem purely from intricacy unfolding over immense epics. Or perhaps, in rare cases, certain motifs bear craft. Certain moments hold purpose. Certain skycrossers bear will, not mere velocity. We lack certainty. Knowledge evades us. For now, with tools at hand for sight and tally. But we can stay receptive to potentials, sidestepping the snare of absolute conviction. In whichever way you lean, if you accept the idea that Atlas is merely a comet, there's a chance you're spot on. Yet you could also overlook humanity's greatest breakthrough by opting for ease instead of challenge, assurance over doubt, the familiar rather than the truly otherworldly. On the flip side, if you sense Atlas represents something deeper, you might be correct. Or perhaps you're just connecting dots in chaos, imposing patterns on mere chance, weaving complex ideas around evidence that points to straightforward causes. True intellectual integrity lies in skepticism paired with vigilance. Skepticism about whether we've gathered enough to decide for sure. Vigilance toward the signals the universe sends, no matter how unsettling or unclear they seem. The heavens remain unmoved by our convictions. They simply exist. And we, fleeting witnesses equipped with flawed tools and skewed perspectives, strive to decipher their signals etched in rays of light, pulls of gravity, and the paths of celestial bodies spanning inconceivable voids. Gaze skyward, yet probe who might have scripted the timeline, if such a force exists. Consider what escapes your notice as you fixate on the obvious. Wonder if the storyline you've embraced is truly your own or one handed down to you. The universe stretches endlessly, mysteriously, and without regard for our tales. But as creatures who craft narratives, the ones we spin about the stars above influence our grasp of our own essence. So weave those narratives with caution, scrutinize them sharply, and bear in mind that the most authentic response to the enigmas of the cosmos may, for the time being, boiled down to this. We remain in the dark, yet we observe. That act of observation marks the dawn of true insight.